Hello, and welcome to part 2 of this section on special right triangles. Last time we were in class, we talked about, or last time in the video, we talked about 45, 45, 90. And the pattern always follows leg, leg, leg root 2, or A root 2. The variable is interchangeable. Just as long as you know which one's the leg, which one is the hypotenuse, you're in relatively good shape to solve for all of the missing sides. Okay, so 30, 60, 90 is our other special right triangle, and it also has its own ratio of side lengths. This one's a little harder, but it is still very, very manageable. You could solve for all of the missing sides as long as you have one of the legs or hypotenuse, one of the sides actually. So the pattern is this. If you have, for instance, we call this, let's label these parts first. In a 30, 60, 90, one angle is 30, one angle is 60, the other is 90. And directly across the 30 is the B side. We're gonna use letter B because in 45, 45, 90, we use A. So this is our B side. The side directly across the 60 is the B root 3 side. And then the side directly across the 90 is the 2B side. What this all means is whatever length B is, this particular side, B root 3, is going to be that number times root 3. And then the hypotenuse is always going to be double what this side is. So if I give you a quick example, if I said, all right, let's write this down first. So it always follows the pattern B root 3, and 2B in accordance with the 30, the 60, and the 90 for the angles directly across. So that's the relationship, always directly across. And I don't know if I mentioned this in the last video, but I'm going to mention it really, really quickly. If it's 45, 45, 90, it follows the same pattern. A root 2. Okay? So if, for instance, I have a leg across the 30, that is 4. Then that means this is going to be the 4 times root 3. This is going to be 2 times 4, which is equal to 8. Okay? And that's pretty much how this goes. If you have this particular side, if you know what B is equal to, the side directly across the 30 degrees, this hopefully is a piece of cake. So, first example, we have 5, X and Y as sides. We could label the hypotenuse if we want to. Personally, I would do this. This is definitely 30, 60, 90 because we have a right angle. We have 30 degrees here, which by default makes the last angle 60 degrees. Then I would go, once I recognize this, I would go ahead and start filling the information in. Side directly across from 30 is our B side. We could set that equal to 5. Side directly across the X is our B root 3 side. So B root 3 is equal to this. And then our Y, our hypotenuse, is going to be equal to 2B. And since we know what B is, we could fill in all of this as so. X will then be equal to 5 times the root 3. We're done. Y will be equal to 2 times 5, which is equal to 10. And then we would be done. So if you have this side directly across the 30, it should just be kind of plug and chug and calculate. Okay? However, if you were given a different side, like in B here, no pun intended, then we have to do a little bit of calculation. So this is still 30, 60, 90 because we have 60 here, 90 here. By default, the last angle is 30. Once you recognize that, start labeling your sides. This N is actually equal to the B side. This M would be the B root 3 side. And then 12 would be equal to 2B. But isn't this an equation? It is. So we could actually start solving for what B is. Divide by 2 on both sides. B would be equal to 6. That's a nice part because now, we have this piece. N would be equal to 6 based off of that information. And then this, the M side, will be equal to 6 root 3. So once you have B, it actually becomes very, very simple to start solving. once you have the value across the the 30-degree side. So let's take a look at C. Okay, this time around, it's still 30, 60, 90. This time around, we actually have the B root 3 side. So we could label this as is equal to B. We could label the 60, the 7 root 3 as B root 3. And then the Y side will be 2B. So this one's a little trickier because we have to account for the B root 3. But once again, this is an equation. Since this is an equation, we could actually solve for B. Divide both sides by root 3. This is the very convenient part because since this B root, this side is written in root 3, 7 root 3, root 3 divided by root 3 cancels out. And now we have B is equal to just 7. So now we could say X here is equal to 7 since that's our B side. And then we could say this is 2 times 7. 2 times 7, which means 14. Y here is equal to 14. All right, one more example, and we'll call it. Here, this is still 30, 60, 90 because we have a 30 degree and a 90 degree, which means this is 60 degrees. Across from this, all right, let's start with the 30. This is our B side. Across the 60 is our B root 3. And then across the 90 is our 2B side. Now this is the unfortunate case because we have an equation here still, so we could solve for it. But we have to get rid of the radical, divide by root 3. This is the unfortunate part because now we have a radical in our denominator, we have to rationalize it. I'm gonna put B is equal to, and then I'm gonna multiply the radical, or the numerator and denominator by that radical. And we're gonna end up with 9 times root 3 is 9 root 3. All over 3, root 3 times root 3 is just 3. If you could simplify again, you absolutely should. 9 divided by 3 is 3, so this becomes 3 root 3. So now we have M. M is now equal to 3 root 3. Because that value follows. And then since B is 3 root 3, this would be N is equal to 2 times 3 root 3, because we substitute. 2 times 3 is 6, and we just leave it, since there's no radical to multiply with the root 3, we leave it as it is, 6 root 3, and this would be our hypotenuse. All right, so 30, 60, 90 is now done. We use B root 3, and 2B to simplify that. If you have any questions, please let me know, and I'll see you in the next one. Bye.